am Dr. S. Thenmozhi, Assistant Professor of Physics, V.V. Vanniya Perumal College for Women, Virudhunagar. Today we are going to see the scanning electron microscope. The scanning electron microscope uses a focused beam of high energy electrons to generate a variety of signals at the surface of solid specimens. The signal that derive from electron sample interactions reveal information about the sample, including external morphology, texture, chemical composition and crystalline structure and orientation of materials making up of the sample. In most applications, data are collected over a selected area of a surface of the sample and a two-dimensional image is generated that display the spatial variations in these properties. Areas ranging from approximately 1 centimeter to 5 microns in width can be imaged in a scanning mode using conventional scanning electron microscope techniques, and the magnifications ranging from 20 to approximately 30, spatial resolutions of 50 to 100 nanometer. The scanning electron microscopy is also capable of performing analysis of selected point locations on the sample. This approach is especially useful in qualitatively or semi-quantitatively determining chemical compositions, crystalline structure and crystal orientations. This is the diagram of the ordinary microscope and electron microscope. Ordinary microscope means light microscope and electron microscope. Now first we see the scanning electron microscope. The mode of action for the scanning electron microscope is similar to compound microscope. However, an electron beams behave like waves which focus via using a magnetic field rather than uses of ordinary lenses. First one is light microscope. We used as a light as a source, and second one is the electron microscope. Here we use the electron as a source. That is the difference between the ordinary microscope and the electron microscope. So the resolution of the modern scanning electron microscope is of the order of 2 nanometer. This compares with the resolutions of about 1 micrometer for a conventional optical microscope. So the transmission electron microscope, in which the electrons passes through a very thin sample, has a higher resolutions than the SEM. So the imaging in the scanning electron microscopy must be carried out under the vacuum, as the electron can travel through the air. So the electrons emitted by the gun are accelerated typically by 20 kilovolt. They pass through the condenser and objective lenses and then through a set of scan coils and an aperture. A scan is simultaneously generated on a computer monitor. The electrons emitted by the specimen are detected, amplified, and the signal is then used to produce a image. Finally, we can get the same image of the sample, particular sample. And these are the electron sources for the scanning electron microscopy. A number of different kind of electron sources are used in the scanning electron microscope. First one is the tungsten thermionic source, and another one is a Schottky field emission source. According to tungsten thermionic source, this is simply a very fine tungsten wire through which a current is passed. This is the characteristics of low brightness and the energy is approximately 1.2 electron volt. Schottky field emission sources, this is a crystal to which a very high voltage is applied. The character is high brightness and the energy speed is 0.5 electron volt. And this is the schematic representations of the scanning electron microscope. This electron microscope follow the same principle of compound microscope but uses the electron beam as a illumination source instead of light. This pictures contains the electron source and electromagnetic lens, sample holder and imaging systems. Next we see one by one. So see, this is the power cable and this one is the power cable, and this is the magnetic lens. Here is the vacuum pipe. This is the electron beam, and this is the airlock one, and this is the sample holder. This is the imaging system for the scanning electron microscope. Next we see the electromagnetic lenses. All modern scanning electron microscope uses the electromagnetic lenses. These consist of a coil of copper wire inside the ion pole pieces, solenoid of wire together with the magnetic pole piece that creates and concentrates a magnetic field. A current through a coil creates a field symbolized by red lines in the diagram. So the electron close to the center are less strongly deflected than those passing through the lens far from the axis. This is the interactions of electrons with the particular sample. See, the X-rays are coming from the source and it penetrate on the sample. We can get the secondary electrons and backscattered electrons from the sample. So when high energy electrons impinges on the specimen, a number of signals are generated. Backscattered electrons, these are the high energy electrons which are scattered out of the specimen, losing only a small amount of energy. And the secondary electrons, this is the originate in the specimen itself and have a much lower energy than the backscattered electrons, typically less than 50 volt. X-rays, these give the informations about the elemental composition of the sample. Next, the information is given by secondary and backscattered electrons. What are the informations we can get from the secondary and backscattered electrons? Are the secondary electrons originate from within the few nanometer from the surface. They are therefore very sensitive to surface structure and provide the topographic informations. Backscattered electrons originate from much deeper within the sample and interact much more strong with the sample. So, provide the compositional informations but give the lower resolution images. Next we see the detectors, that is the secondary electrons. The detector for secondary electron is the ever heard Thornley detector. This consists of a scintillator that emits the photons when hit by the high energy electrons. The emitter photons are collected by a light guide and transported to the photomultiplier for detections. A metal grid known as a Faraday gauge surrounds the scintillator. It is usually held at a positive potential to attract the secondary electrons. Next, the backscattered electrons. The backscattered electrons can be detected using the Everhard detector by applying the negative potential to repel the secondaries. So, the collection of efficiency of such an arrangement is low. As the name suggests, the electrons, which means the backscattered electrons, are strongly scattered by the direction of the incident beam. So, the detector for these electrons is generally placed around the final lens. The backscattered electron detectors are usually solid state devices. The electrons which impinge on the detector produce the electron hole pair, which produces the current which can be amplified. And this is the image taken from the SIM instrument, scanning electron microscopy instrument, for the biological samples. So the electron microscope allows the biologist to explore the cells in more details. And first one is a Golgi apparatus, chloroplast and mitochondrion and endoplasmic reticulum for the biological sample. And this, the electron microscopes are used in scientific laboratories and many industries such as Forsenic department, mining and nanotechnology department. And next we see the applications of the scanning electron microscope. The scanning electron microscopy is routinely used to generate the high resolutions images of shapes of objects and to show the spatial variations in chemical compositions. First one is we can get the elemental maps or spot chemical analysis using the EDS analysis, which means energy dispersive analysis, X-ray analysis. The discrimination of phases based on mean atomic number compositional maps based on difference in the trace element activators. Second one, the SEM is also widely used to identify the phases based on qualitative chemical analysis or crystalline structure. Precise measurement of very small features and objects down to 50 nanometer size is also accomplished using the scanning, which means the scanning electron microscope instrument. The backscattered electron images can be used to the rapid discrimination of phases in multi-phase samples. SEMs equipped with the diffracted backscattered electron detectors can be used to examine microfabric and crystallographic orientations in many materials. Next, we see the disadvantages of electron microscope. First one is it's a large machine. Training is required. It's very expensive. The specimens are required to a lot of preparations, and the specimens are mounted in plastic, which means that only dead cells can be viewed. And this is the difference between the ordinary light microscope and the electron microscope. According to the light microscope, it's cheap to purchase and cheap to operate, small and portable, simple and easy sample preparations, materials rarely distorted by preparations, vacuum is not required, and the natural color of the sample is maintained. Next, we see the electron microscope. It's very expensive, and it's expensive to produce the electron beam, and large and require the special rooms, lengthy and complex sample preparations, and preparations distorts the material. Vacuum is also required, so all the images is in black and white. So this is the major difference between light microscope and electron microscope. So this is the reason only we follow the electron microscope for sample preparations, sample analysis technique. Thank you.